Okay, you'll notice in the past talks we've only been considering sine and cos. What about tan? Let's have a look. Let's see if I can draw myself a reasonable circle. Wish me luck. That'll do. I'm going to put axes through it. And I'm going to place 30 degrees in there because that was the one we looked at before. And we knew that the coordinates here, the x and y coordinates, we knew that the x coordinate was cos 30 and we knew that the y coordinate was sine 30. And this is on a unit circle, so that length there is 1. If you like, I can put the 30 in there as well. Now, finish this triangle up and let's look at tan 30. So tan 30 is opposite. And what's my opposite? Ooh, that's sine 30 over adjacent. Okay, so that's the opposite and that's the adjacent. The adjacent is the x coordinate. Ooh, that's cos 30. That's what we learnt last time. So that's an interesting thing to note. In fact, that's a general result. We can say that tan theta is sine theta over cos theta. And in my example here, we can go to my special triangle, put the 30 where it goes, the 60 where it goes, just so we know which way around everything is. And let's look at this. We know that tan 30 is opposite over adjacent. Right, let's check that out. Tan 30 is opposite over adjacent. But we also said that tan 30 was the same as sine 30 over cos 30. Well, let's see if that pans out true. So sine 30 over cos 30. Well, my sine 30 from this special triangle is opposite over hypotenuse, and cos 30 is adjacent over hypotenuse. And you might remember from your days in Year 7 that when you actually have two fractions which are divided, we can times by the reciprocal of the second fraction. And hopefully a simple bit of simplification, and you can see that that's in fact 1 over root 3, so that does bear out. See that? That 1 over root 3 from going sine 30 over cos 30 is exactly the same as the 1 over root 3 from just going tan 30. So yeah, tan is sine over cos. That'll be interesting for us in the next section.